x of t is a periodic signal. Now we know if x of t is a periodic signal, so periodic signal will be represented, can be represented, periodic signal do represented as a Fourier series. That means this is the two way of representing a periodic signal, that is your exponential form and there is a triangular form. Now here I choose to represent it. So exponential form is a quite easier form through which we are going to find out Fourier transform of this thing na. So that is a exponential form is a very easiest way to do this. Now we took a exponential representation of this periodic signal x of t. Now we took a Fourier transform on the both side. We took a Fourier transform of this side and also we're going to take a Fourier transform of this side. Now if you do so, we know this summation into Cn, this Fourier coefficient, this can be came out, this value will going to lie one part, yes or no? This value and this value can be separated, yes or no? Now this part, if we know, just calculated what will be the Fourier transform of e to the power j n omega naught t. So this value will be nothing but 2 pi, we just calculated this value, no, 2 pi del of omega minus n omega naught. Okay, here what is the constant value? That is n omega naught. So this will be n omega naught. Very important observation. Now baki ke n is equal to minus infinity to infinity into Cn, it is there only. Okay, the only extra fact which got modified is 2 pi del of omega minus n omega naught. Very important observation. If your time domain representation is a periodic function, if your function is periodic, so you are going to get impulse responses where very important point, where Fourier transform of a periodic continuous time signal consists of impulses. We got here now, what is the value that we got? 2 pi del of omega minus n omega naught. So this is nothing but various impulses located at the harmonic frequency of the signals. Like for example, I'll show you an example. Please remember this point, because if there is a periodic function is there, if you are taking a Fourier transform of that periodic signal, then in frequency domain, the impulses that you are going to get, those impulses, the location of those impulses will be nothing but at the harmonic frequency of the signals. How? Look here carefully. I took a train of impulses. I took an example of train of impulses and I did the Fourier transform of this train of impulses. You can clearly see all the harmonic value, the actual impulses that we got in Fourier transform, those impulses will nothing but going to situated at on the harmonic frequencies of these signals. Okay, there is two things you need to remember here. Very important two observation. First of all, please remember, impulse signals, the Fourier transform of a train of impulses is nothing but train of impulses only. Second point is this: the Fourier transform of any periodic continuous time signal consists of impulses located at the harmonic frequency of the signals. You can clearly see here. Please have a clarity on this concept. This concept is very important. Okay, you can clearly see if you take the magnitude spectrum of this function, you can clearly see the impulses which is replaced by impulses only: omega naught, 2 omega naught, minus omega naught, minus 2 omega naught. Clear this concept? This is a very important concept. Okay, two things you need to remember here. First thing, the train of impulses, Fourier transform is a train of impulses. Second thing is the Fourier transform of a periodic continuous time signal consists of impulses located at its harmonic frequency of the signals. Clear this concept? This is the magnitude spectrum and this is the real spectrum of the actual signal. Okay, please remember this thing. Please write it down in your own language on your notes. Moving on to very important note point. From here onwards, I'm going to deliver you 2 to 3 note points which are associated with the time shifting property. One note point is associated with the time shifting property. Another note point will be associated with the frequency shifting property. Okay, now in time shifting property, you can clearly see the Fourier transform of a time domain signal. The Fourier transform of a time domain signal, I'm sorry, x of t is, if it is x of omega, so we know the formula, we know the property, time shifting property, x of t minus t naught will be nothing but x of omega into e to the power into e to the power into into e to the power minus j omega t naught. Okay, please have a like 100% concentration here. Look here carefully. If there is a t plus t naught, you're going to get e to the power j omega t naught. That is a minus t naught, and here you got plus t naught. If here it is a plus t naught, you'll get plus t naught. If it is here minus t naught, it is you're getting a minus t naught. I'm really sorry. This thing you need to read it in this way. It is actually plus t naught. Okay, you just need to remember always in this format only. Please have a clarity on this. X of when I'm saying x of t minus t naught, that means I'm saying t minus plus t naught. Please have this clarity in your mind. When I'm saying x of t plus t naught, that means I'm saying x of t minus t naught. Please have this clarity in your mind. So this expression is this expression is this. Please have a clarity on this point. Okay, so when we are having a plus t naught in time domain, in frequency domain it is converted into minus t naught. Okay, it is nothing but instead of writing it in this way, I can also write down in this way minus t naught. Yes or no? Instead of writing down in this way, I can also write down plus t naught. Yes or no? So you can see here, when your time domain, in time domain it is plus t naught, in frequency domain it is changed to minus t naught. When you have a time domain minus t naught, in frequency domain it changed to plus t naught. That means, but there is no change in magnitude spectrum. There is no change in magnitude spectrum. Only changes is happening in a phase spectrum. So please remember, in time shifting property, there is no change in magnitude spectrum. But in frequencies, in phase spectrum, there is a change is happening. So please remember, time shifting property affects the phase of the system or the signal or the function with which that we are doing the evaluation. Please remember this point. Okay, this is a very important point, that phase spectrum is always gets affected, not the magnitude spectrum, in time shifting property. Shifting in the time domain does not affect the magnitude spectrum of Fourier transform. It only affects the phase spectrum by omega t naught or minus omega t naught. Clear this concept? This is a very important and very simple concept, and please have a clarity on this thing. Please do remember in this way, the way I represent it to you. Okay, this is x of omega. Let me write it down properly. Okay, moving on. There is a very important and conceptual example that I'm going to discuss with you. Please look here carefully. Okay, I want your 100% attention here. This is a very important property actually. Just need to look here carefully. You have a x of t and you have a g of t. X of t looks like a sawtooth pulse which is distributed from -1 to 0, and g of t looks like a pulse, like normal rectangular pulse within -1/2 to 1/2. we're not concerned about what is the magnitude. It could be a 1 or anything. Okay, the question it is saying, if x of t, the Fourier transform of x of t is x of omega, then find the Fourier transform of a g of t in terms of x of omega. It is very simple example, very simple example. You can quickly say, sir, what I can do, we can convert this x of t in the form of g of t. That is how this g of t looks like. I can convert this x of t in a g of t format. That is, I can draw like this. I can make it in this way. X of t can be shifted to -1/2. Okay, and also here to 1/2, and also here this x of t is another x of t. It can be modified in this way. So I can find out the expression for this equation, and this is nothing but g of t only. This is nothing but g of t only. Please remember, do solve it in this way. So if you do find out the equation of this is nothing but the modified version of x of t, which tends to represent g of t. The value will be nothing but x of minus t minus 1/2 plus x of t minus 1/2. ये किसका expression है? Whose expression is this? This is the expression of this. I'm really sorry. This is the expression of this function. Clear? Minus 1/2 plus 1/2. And this is the expression of this one. This is your g of t. Clear? Now, what is the important concept here? Look, we need to find out the g of t in terms of x of omega. Okay, for that you need to find out the x of omega for that is the Fourier transform of this expression, and also Fourier transform of this function. Also you need to find out a Fourier transform of this function. So the Fourier transform of this function, if it will come out to be x on omega, the Fourier transform of this function, if it come out to be x to omega, then the summation of these two function will nothing but the Fourier transform of g of t. That means they will come in the form of x of omega only, no? Now, because we know the Fourier transform properties, that it obeys the linearity properties, you can find out if it is in an addition format, you can find out the Fourier transform individually. What is that important point? X of t minus 1/2, you can easily find out what is the Fourier transform. So that will be nothing but x of omega into e to the power minus j omega by 2, or j omega, you can write down j omega into 1/2. Okay, time shifting property. Now how you're going to find out? Here it is the concept. How you're going to find out the Fourier transform of minus t minus 1/2. Please remember it. Please follow this pattern. This is the pattern that you need to follow. What you need to do, just need to convert it in this format in your mind, that is x of minus omega, okay, into e to the power j omega into 1/2. Clear this concept? This will be your answer for this thing. So how you have calculated this thing? Because what you need to do in your mind, you need to take it in this way, minus, you just take common minus. Okay, now after getting this expression, you can clearly see this plus wala term. Okay, you can represent in this way, x of minus t1, where t1 is nothing but t plus 1/2. You need to break this shifting thing in your mind, and in minus t, x of minus t in frequency domain, it will be nothing but x of minus omega only, no? So x of minus omega 1, you can say in this way. Now if you break t plus 1/2 in your mind in frequency domain, you can represent it in like minus omega into e to the power, for t plus 1/2 e to the power j omega 1/2. This is the concept that I wanted to share with you. Please do solve it in this way. please do take a common of minus, okay? And you know, if there is like this kind of condition, please do this thing in this way. Please remember the Fourier transform of this function will be nothing but x of minus omega into e to the power j omega 1 by 2. Clear this concept? Now here in the answer that we got, this is nothing but plus of both these expression. Okay, so x of omega, g of omega that we got here, that is nothing but this is what he asked. No, just find out g of omega in terms of x of omega. Now this is your answer. Okay, you got your answer. Now let's move to next question, next kind of format. Look here carefully. We know this is a frequency shifting property. It's a very important example, a very important discussion, and I want 100% attention here, my friend.